Good afternoon. Can you hear me? Okay. Okay, so let's just wait for others to join and then we can start. Okay, I'm gonna start as we wait for others. So, what's the time? So today we are going to do that chapter 8. So it's all about hypothesis, testing hypothesis. Okay, so the first question here is saying a new low fat fag bar is advertised as having 120 calories. The manufacturing company conducts regular checks by selecting random samples and testing the sample calorie average against the advertising average. The most recent sample consists of the following calories. So you can see here there are two samples. So they are testing sample let me stop sharing because I think it's not. I must share again. Okay, so it's saying that you must check by selecting random samples and testing the sample calories average against the advertising. So there are sample calorie average against the advertising average. So there are two variables that you need to test. So these are the things that you need to note when you are reading questions of hypothesis. Okay. And now the first step in doing hypothesis, you first have to find what is the null hypothesis, what is the alternative hypothesis. Alternative hypothesis is the thing that we want to find. Like, for example, testing the calories against the advertising averages. So that's our alternative hypothesis, a two-tailed test, okay? And then you find your critical values, then you find your test statistics, then you make your conclusion. Okay, so the first here, you are given your now hypothesis is 120. They give you having 120 calories, so your now hypothesis 120. As I already said, that your alternative hypothesis is the thing that you want to try to find out. That's your alternative hypothesis, and that's the calorie average against the advertising average. That means the two means. You need to find out if these means are different. Okay, so it means that the alternative will be mean is not equal to 120. So it's a two-tailed test. All right. So after finding your hypothesis, you need to find the critical values. On the critical values, the first thing that you must know is what is your N. If your N is less than 30, you have to use T distribution. If your N is more than 30, you have to use Z score. Okay, so given our question, we can see that our N is less than 30. Okay, how do I know my N? Okay, I'm given the samples. These are the samples that I'm given. Okay, so how many N's do I have? I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our N is 15. Okay. So we already established that our N is less than 30. So our N is less than 30, then thereby we're gonna use T distribution. And because T distribution, you have to find N minus 1. Our N is 15. Here is 15 minus 1 is 14. You check on your table, you check what is your alpha. Our alpha here is given 5% significant level. So remember that 5% significant level is the same as 95%. Okay, they can say 95% or 5%. They can also say 10% or 90%. It's the same value. The answer will be 0.05. Okay. So as you can see there, you have your alpha. Your alpha here is 0.05. You check on the table, you find that, and your alpha, you're gonna define it divided by 2. Why am I dividing by 2 alpha? Anyone? Why am I dividing by 2 alpha? Anyone who wanna say something? Why is alpha dividing by 2? Why is alpha divided by 2 here? Why is alpha divided by 2? So you divide your alpha by 2 because it's a two-tailed test. Okay, a two-tailed test, you divide alpha by 2. If it was one-tailed test, that means alpha is less than or greater than. If they ask you to find you something that is less than the other, then you don't divide by 2. Okay, so you check on your T distribution table, your critical value is 2.145. Okay, so now after finding your hypothesis, your critical value, you go to test, you go to t-test. Okay, can you guys mute yourself? I can see someone is talking. Okay, so the t-test, first here, the trick is you need to know which formula you are using. Remember, this is a T distribution, and of the mean of a single number, the difference between two-tailed tests. So you can't, you have to know which formula is the best to use here. Otherwise, if you use a long formula, the answer is also wrong. So you use this formula because it's the, you're finding the difference between, it's not a proportion, it's the mean, but it's just that the alpha, the n is less than 30. That's why you are using this formula. So from this formula, this x bar is our mean. So this is the mean that is found from this table, okay, expected mean. So you know how to find the mean is just adding all these values, divide by the total number, which is 15, okay? So that is 120.667. The mu is already given. So that's what the null hypothesis is, mu equal to 120, okay? That is 120 there, okay? And the S is the standard deviation. So this number here is the standard deviation from what is given. So you are given a table here. You find your standard deviation by subtracting each of these. So it's 99 minus the expected mean that you found. So it will be 99 minus 112.666 squared plus 127 minus 112. So you squared plus, so you continue adding all this until you finish to the end, and then you find your answer. Then you divide by n, which is 15. Then you find your answer. That's your standard deviation. Okay, I hope you all know how to find the standard deviation. And then you square root 15, which is your n. Okay, so you find this number. Okay, now you need to make a conclusion. So now we found that our t-test, our test statistics is 2 point. We found that our test statistics is negative 2.369, yes, 96. Therefore, for us, we need to decide whether we're gonna reject the alpha or accept. Okay, so we're only gonna reject the alpha if t is greater than 2.145, or if t is less than negative 2.15. So our answer is negative 2.3695. This is this is greater, this is less than that one. So remember, with negative numbers, the one that is small is bigger than the other. Okay, so this one is bigger than that one. Okay, so our test statistics, which is this one, is less than that one, the critical value. So because our test statistics is less than the critical value, which is negative 0.2145, therefore it means that it falls into the rejection area. Therefore, we can reject the null hypothesis. Okay, so what it means is that there is a difference. So we can accept our alternative hypothesis, which saying that there is a difference. Okay, if we reject null hypothesis, that means we can accept it. But if it was the other way around, let's say this one was greater than that one, then we would not reject the null hypothesis. Any question? Any question?
No questions, ma'am. Thank you.
Okay. Okay, thank you. So I'm going to do question 2. So question 2 is saying, occupation health representative of a mining union has claimed that 30% of the union members employed at the coal mine suffer a breathing and chest problem called coal mine dust lung disease. The mine company is hoping to prove that this number is not as high as the union. So remember what they are asking. They want to prove that this number is not as high as the union claimed to be. Okay, so this word is very important. And then they say that contact a small district. They made a survey of a small district district study only the randomly selected sample of its mine workers, and the study showed that 145, so 145 of the mine employees included in the study, okay, included in the study suffer the disease, okay, they suffer from the dust lung disease. The mining company would like to know if they can use these results to refute the claim that is made by the health representative. So the claim is to prove that this number is not as high as the union claimed to be, okay? And then we have 1% significant level. So the most important thing to note is what I've here highlighted. This is a study of 1/5 of 540. So you should know that's a proportion, okay? So I'm not dealing with any other value but proportions, okay? That's our p-value, okay? So our hypothesis, and also what they are proving, they want to see if that p-value is high as they claim to be. So they want to prove that it's not as high. It's not as high, meaning it's less. If it's not as high as it used to be, then it must be less. So that means that proportion must be less. So remember, what they claim to prove is always the null hypothesis. What they want to prove is always the alternative hypothesis. So our null hypothesis is always p equal to 0.30. This 0.30 is 145 divided by 540. Okay. So now our alternative is what they are proving. They want to prove that it's not as high as they claim to be, meaning that it's less than. Okay, so that's a one-tailed test. So it's a test to the left. It's a one-tailed test, meaning that your alpha don't divide your alpha by 2 because it's one-tailed test. Okay, so then you are done with the hypothesis. Then you go to your critical values. Okay, so how do you find your critical values? What you need to know is what can you use? It's a proportion. You use you find out what is, whether you use Z value or T value, and you have to know what is your N, okay, to decide that. So you know that your N is 540. Remember, it's 145 of the 540. So 540 is greater than 30. That means I can't use T values. I have to use Z normal values. So that's why we are using Z there. And we are given alpha of 1%. 1% is the same as 99%. So 1% is 1 divided by 100, you find the answer is 0.01. All right. Okay, so there you have, so you check this on your standard deviation, on standard normal tables, you find that that's the figure here. Okay, so that's your critical value, but then they're asking you for something that is less, remember? So your critical value, your Z value, what they're asking you for you to conclude, you need the Z statistics here. The Z statistics must be less than negative 2.325. Why is negative? Because here it's less than, okay? So that's why you need to find a value that is less than negative 2.321. Okay. So you may find your critical value is positive, yes, but they're asking you for your alternative is the negative value, all right? So when you do your test statistics, you only reject the null hypothesis when your Z score, which is your Z score, your Z this Z statistics is this what you're gonna calculate here. If this is less than -2, then you reject your null. Okay. So again, because this is a Z-score of proportion, you use the same formula that you use for confidence interval. The one when you are doing your confidence, you are using this formula for proportion. Okay. It's not two proportions. That's why it's only for the formula is only for one. Remember, there is also another one for two proportions. Okay. And then I just want to explain what's going on. So P bar, this one here, the P bar, the first one is this one. So it says it's the proportion of the first values of what is given. So we are given x 140 of 540. It's just the proportion. Okay. So that proportion that we found here, it was 145 over 540 minus P0. Okay. P0 is our proportion value that we found there, which is 0.013. Okay. Okay. Remember, our proportion here is 30%. He claimed that 30% of the union. That's our proportion. Sorry, I made a mistake. I think I told you in the beginning that 0.5 is 145 over 40. No, it's actually what he's claiming to be. So he claimed 30%, which is 0.035. Okay, so take note of that mistake. Okay, so our proportion here is 145 over 5 minus 0.5. P0 is 0.5, our proportion. Okay, then you substitute, n is 540, you just substitute, you find this, that's the number. So anyone who wanna say what will be our conclusion? Should we reject or accept now? So what will be our conclusion? So our test statistics is negative 0.5. So negative 0.5, you have to compare it to the critical value. The critical value, this one, the negative one. Is it greater or less? Then you make your decision. So what will be the decision? Anyone? Should we reject null hypothesis? Okay, yeah, I can see on the chart is saying reject, yes. Okay, because the reason is because this one is greater than. So remember, -1 is always, so -1 is always greater than the Z-score. So we can't reject it. Why? Because remember, you must check the values. Negative 1.5 is greater than this one. This one is not greater than. This one is not greater than this one. Remember, when we are dealing with negative values, the number that is smaller is always greater than the number that is bigger. Okay, so this one is greater than that one. Therefore, we do not reject. All right. Any question? I can see that most of you said you must reject it. I understand because you were looking at the values here. But remember, you don't look at the values here. You look at what is given. Remember, it's a P less. So it must be, the value here must be negative. So you can only reject if your t-test is less than that one. Okay. So it's not less, it's great, because this is greater than negative 2.325. All right. So this is a critical thing you need to figure out. When you find your critical value, remember what's your alternative. Your alternative is not greater than, it's less than, meaning that your t-test must be less than negative value. All right. The critical value is not negative, because when you look at the tables that the Z-score table, they always give you a positive value. It will not give you the negative value, it will give you the positive value. That's why it's positive. But you have to change it, because remember, you are looking at one side to the left. So but the on their table, it will give you the one to the light. They will give you the one to the light, but you want for the one to the left. That's why here you say you can only reject if Z is less than negative of that, because it's one tail test. If it was greater than, you will just leave it as it is. You don't put a negative value there. Okay, I hope I've answered your question. In the chat, I saw a question. Okay, any more questions? Okay, so I'm gonna continue. So the conclusion here is that the Z statistics is more than the critical values. So it means that it falls into rejection area, therefore H0 cannot be rejected. Therefore, it's not enough there's not enough statistical evidence to prove that less than 30% of union members, they suffered the lung diseases. Therefore, we refuse the claim that the population proportion of employees that suffer mine disease is 30%. Okay, so the claim is wrong. Okay, so question 3. Okay, I can see in the chart is saying, if we are to draw a distribution, would there be two critical value, like the positive and negative one? Yes, but remember what the question is saying. The question is saying that you must find some, the alternative here is you must find one tail test, the one to the left, but the values that is given is always to the light. It's always two tail test or to the light. They give you values of to the right or two tail test. Okay, so it's never negative. Therefore, you have to change. Okay, if you are doing one tail test to the left, you change. But if you are doing one tail test to the right, you leave it as it is there. So all you need is just to find your T values and compare it with the critical values there. And the same rule will require, if your T test is greater than that one, you do not reject. If it's less than, you reject. Okay. So the rule here of comparing doesn't change. Okay. So question 3. Question 3 is saying that question 3 said the rate of hay fever in Eastern Cape was studied, and the research was focused on 2 age. I just want to see how much time. Okay, it's saying the rate of hay fever in Eastern Cape was studied, and the research was focused on 2 age groups, specifically people under the age of 12 years group. Okay, so that's group 1. They already give you, take note of that. Okay. And people over the age of 50 years old, so group 2, and they given the random sample of 16. So the first N1 is 16, and then the community, it was found that the average rate of the fever of 21 years old is this. So that's the mean for the first one, and the standard deviation was 5. So for the first group, the second group, our N is 17 for the random sample of 14 communities in the province. It was found that the average rate of hay fever of the people 50 years old was this, and the standard deviation was that one. So that's N2, that's the mean 2, and then standard deviation 2 of the second group. So they're asking to test 5% significant level whether the people in the Eastern Cape have a lower rate of hay fever than people under the age of 25 years old. So so that's like two things. There are people for less than age 25 years and 50 years. So our null hypothesis will be N1 is equal to N2, and our alternative will be N greater than. So they're asking, remember the claim is whether the people in Eastern Cape over the age of have lower rate. Okay, test where these people have, whether these people have lower rate. Okay, so it's less than, meaning that the people with N, so N1 must be greater than the other one. N, remember the mean of the N1 is the first group. So the first group must be greater than because these ones have lower, they have lower rate. Okay, so that's why here your hypothesis. Remember your hypothesis is always what, your alternative for hypothesis is always what they want to find out. Okay. So that means it's a one-tailed test to the right. Okay, so you don't need to do negative like we used here. Remember, we said it must be negative. So here, because there are two-tailed tests, it's N1 plus N2 minus 2, which is 16 plus 14 minus 2, which is 28. Okay, you find that your alpha is 0.055% is the same as 95%. And you find your critical value as this one. You don't change it here. Why? Because it's greater than. You want to find something that is greater than. Therefore, your t-test must be greater than 1 for you to reject the null hypothesis. Okay, so finding the t-test, this is just x1, the mean, the first mean. Your t-test is your first mean. But first, before you do that, because this is for two value, you use the formula for the two value. Yeah, and then you must first find your CP. Your CP is found by this formula, this whole formula here. Okay. Your N1 is the 16, N2 is 14. Remember, don't confuse. If they tell you that group 1 is N1, then you must focus on that. Okay. And then your S2. Your S2 is 15. That is your mean that was given, your standard deviation. Okay, this is your standard deviation that was given for the population, for the first population. And this is the standard deviation for the second population. So S squared 2 is, these are standard deviation. And these are N plus N of the first one and the second one. Okay. Then you substitute into the whole thing. Remember your X bar, these are the means for the first one. But don't confuse, the N1 must be N1, N2 must be N2. Now you find your t-test as 2.0.135. So what will be the decision now? Should we reject now or? Remember your t-test is this one. Should we reject now or not? Remember, you can only reject if the t value is greater than 1.25. Okay, so you can see t value is greater than 1.27. So therefore we reject. I can see someone said reject in the chat. Okay, so we reject it. Okay, so there is enough evidence to conclude that the people from Eastern Cape that are over 50 years old have a lower rate of hay fever compared to those who are age 25 years old. Okay. Okay, let's do the last one. So the last one is an investor want to determine whether a new lecture is that is hired is working out well. For a sample of 40 students, so that's your N, 28 students passed a certain test on their first trial. Okay. In a more experienced lecture B, so there is lecture 1 and lecture B, 50 students passed the test on their first trial. The test of 10%, at 10% significant level whether the success rate of the experienced lecture is better than. So the success rate, test where the success rate is better than that of a new lecture. So you must know a new lecture is letter A. So what they're asking you now, hypothesis, is whether PA is equal to PB, okay? But they're asking if the new lecture, which is PA, so they're asking the experienced lecture is better than that of the new lecture. So this one, PA, which is your new lecture, must be less than PB. PB is better. So that's why PB is better, PA is less than PB. Always remember what they first, what they start you with, this must be the first thing that must be there. Okay, so it's a one-tailed test. Again, you find your Z scores there. Your Z score, your critical value is 0.5. You don't divide by 2 because it's one-tailed test. Okay, and then you find your t-test. Your t-test is 0.25. Or PA and PB, these are just the values. Okay, so you must find the values that will be 28/20 and 38/30. Just the proportion. Remember what they give you already in the question there. Okay, so your P alpha is the 2, so you must add the 2. So it's actually 28 plus 38/40 plus 50. So it's just the formula. You must know how to copy. Then you find your P bar is equal to 66/90. Okay, so now your t-test is this one. But remember, this is a one-tailed test, and then it's to the left. This means that your critical value must always be negative. So you can only reject if your Z value is less than -1. Remember, they're using Z values because the N is greater than 30. So should we reject or accept? So remember again here, they put a negative. Why? Because it's a one-tailed test and it's to the left. So you can only reject if Z is less than -1. So we can see that our t-test, okay, let's see our t-test. Our t-test is 0.5, which is greater than that one. Therefore, we do not reject. Yes, correct. Yes. Okay. Thank you so much. So that's the end of our Tut today. Any question? So you make a conclusion. Your conclusion will be saying that we do not reject because it doesn't fall into the rejection area. Therefore, H0 is not rejected. There is not enough evidence to prove that the success rate of experienced lecture is better than that of the new lecture. Any question, guys?
Ma'am, there's less than 1 minute left. So can I ask you the question in WhatsApp? Yeah. Because I don't think you'll be able to answer it now.
Yeah, you can ask me the question in the WhatsApp. Yeah.
Okay, thank you.
But please practice this